Hello, this is Team Simio LED, and with this presentation, we will be describing the model that we created for this year's Simio competition. Our model is simulating a clinic and urgent care facility to show an optimal design, as well as the way that the workers and entities inside this facility operate and move. Since, according to the problem provided to us, the SCUC institution wants to add a new facility, the requirement was to model a clinic that provides different types of medical services, whether they are scheduled for an appointment or they are unscheduled, but of course they need to be treated or they need to receive some type of medical attention.
As you can see, this is our entire layout. And as you can see, we started off from, our layout is going to go from the left-hand side to the right-hand side. Starting off with the waiting area. As soon as entities are created, as soon as the patients come in, they're going to go walk through the waiting area and immediately hit the reception desk. All this is going to be connected with paths. From the reception, we are going to connect, we're going to go from a transfer node into the triage areas. We have, as you can see, we have 4 triage areas. The amount of triage and rooms that we have is based on the data that we were given for the Simio competition. All these, in order to connect all the rooms, all the triage areas, we had to place a transfer node to be able to connect them all and link them into a single point when they come out or in. From the triage areas, we go into the exam rooms. Again, 4 exam rooms connected with transfer nodes. As you can see, on the far left hand, we have the imaging room. We placed it right next to the exam room since most entities go from the exam room to the imaging room. These are, in the sequences, these 2 rooms are really close by, so it only made sense to connect them together, to place them so close together in the layout. Here are going to be our 4 procedure rooms. These are usually one of the last steps in our sequences, so they are at the other side of the facility. The last station we have is going to be the lab station. This is where the lab technicians and lab doctors take the samples, deliver the samples, and then again, everything else is just connected back with paths. As you can see right here, we have the node home for the doctors and lab technicians. This was necessary so that they wouldn't just be walking around, so that the workers wouldn't be walking around, and they had a specific section to go home to. Once the entity is ready, they will go follow the path, pick up the entity, and drop them off at the designated location.
Now for the entities, according to the information that we received, we came to the conclusion that this clinic is visited by 8 different type of patients, which we assigned a source for each. As you can see, there are the type of patients that we have. Those are those that are scheduled for checkup and scheduled for casting. There's also patients that decided to cancel, so we had to take that into account. And then the unscheduled patients that are those that need treatment but are stable, that need an urgent treatment, that will have a lab requested, and that need a casting. All these entities have their own source that they walk out of and then walk to the entrance node before they follow their own sequence. Before we show you how the model runs, we will be describing the different sequences assigned to each type of patient. All sequences start off with a sign-in process, which begins at the reception desk and is followed by a back and forth sequence between the waiting area and the reception desk. However, after this, sequences branch into scheduled and unscheduled. So depending on their medical need, they will be taken to different rooms, especially because unscheduled patients must go to the triage room first.
Okay, so now we're gonna show you how this model works when it's running. So like Eric already explained to you, each patient follows a sequence according to the medical need that they have. So let's run it. So of course they go to the reception desk. As you could see there, a nurse picks up the patient once it arrives to the triage node. Right now, the patient is waiting for a nurse to come pick it up. And it just happened, as you could see. Here, these two nurses, they only pick up the patients that are scheduled, whether they are scheduled for an image appointment, so a casting appointment, they need to go to the casting room. So here you can see that the doctor just arrived. Once the doctor detects that there's an entity in the imaging room, the doctor will arrive and will attend the patient. And of course, the nurse will be there waiting for this patient because the nurse needs to follow the patient at any time. The patient can be left alone. So when they walk from a room to another room, they have to be followed by a nurse. The nurse has to help them. So for that, we assign different nurses for the different areas that we have here. So we have nurses for the triage rooms. We have nurses for the exam rooms. One, like I explained, two that help the scheduled patients. And of course, we also have nurses for the procedure rooms. So let's take a look, for example, at this room. Here, there's the doctor, the patient, and the nurse, because this patient is currently being examined in the exam room by this doctor. And they're waiting. Of course, each room has a certain time, a specific time for its process, as well as the entities. They have different inter-arrival times. So that's how the model works. Once it finishes being here in the exam room, it will go to the procedure room, or maybe it will go to the lab. It depends on the sequence that it was assigned to. And of course, before they leave, they gotta go back to the reception desk, and then they will follow this path to exit the building through this door. One thing we also want to show is, like Luis was explaining before, there's a doctor station here. And every time a patient arrives to a room, of course, the doctor has to go to check on them. And we're gonna briefly show how we did that. So I'm gonna stop running the model. I'm just gonna click on this. So as you can see, this doctor, first of all, it follows a work schedule. So we were told by the Simio contest, by the data that we were provided, that this hospital or this clinic runs from 10 a.m. to 10 p.m. and that there's doctors for the morning, there's doctors for the afternoon. So we decided to just give this different doctors different schedules. You can see those here in the data. There's different schedules, two different schedules, and the hospital runs from 10 a.m. to 10 p.m. So these were assigned to each of them. Now we also briefly just want to show you how we made it work in order for the doctors to go to the room once they detect the patient, and that's just simply by adding a secondary resource. Here, as you can see, for this server, we added 2 rows, which I'm gonna briefly show you. This is the first of all, this one says that if there's an entity or a patient inside that room, then exam doctor number 2 has to go to that room, and the patient will not leave the room until exam doctor 2 finishes checking on him. And then the patient also is not able to leave until nurse 2 goes and picks him up. So, because again, these patients can't be left alone. They need someone to follow them to the next node. And then here on this node, someone else will pick them up. I'm sorry, here in this node, nurse 3 will pick the patient up and will take them to the procedure. So that's how we made that work. Of course, for procedure nodes, there's different doctors with different paths. And same thing with the lab, same thing with the imaging room.
Here you could see our experiments that we ran. As you can see, the first 6 responses are going to be our average time in system for different types of entities that we have. The next responses are going to be the utilization for our lab, our triage, and our imaging, followed by the max Q waiting room. This tells us how many people, what's the maximum number of people waiting in line at a given room. The next one is going to be the work in progress for the lab. This is another experiment that we're running. And then lastly, we are running the number of times processed for reception. In order to run this experiment, we had to create a statistic tally. And then from there, we had to create a process where we added a tally. And then the values as you could see. Lastly, we noticed on our experiments after running them for 3 different scenarios, and the scenarios run with for 10, 20, and 30 replications. We noticed that the utilization for the imaging was going to be really high. So then our attention is focused on the imaging. That raises red flags. That tells us that something needs to be done in order to decrease that amount. This could either be by increasing the number of doctors, or maybe including another imaging room in order to be able to decrease this number, since it is the number that is causing the most. It's the room that's being used the most. Here is a last look of our facility. That's it for our presentation.